Lesson 11-9 Transformations, and in this lesson you learn to identify and draw reflections, translations, and rotations, and to identify and draw symmetric figures. Why is it important? Because when you classify animals in science, you will use symmetry. So let's take a look at this hands-on activity. If you look around you, you'll probably see geometric shapes repeat in repeating patterns. Floors and ceilings are often tiled in patterns. So in the activity below, you will investigate one way to create a pattern. So what you want to do is cut out a triangle out of cardboard, probably a piece of paper. Place a triangle on the coordinate grid as shown, okay, so that one side lies parallel to the x-axis. So that side lies parallel to the x-axis. Trace the triangle on a piece of paper. You're doing the pink triangle right there. Label the vertices shown. Write coordinates of the vertices. So if you want to write the coordinates of our vertices, x coordinate would be 1, 2, 3, 4. So this is 4. X coordinate would be 4, 1, 2, 3, 4, 3. Our y coordinate would be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So that's going to be 8 and 6, our y coordinate. And our z coordinate would be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 7, and 3. Okay, so after writing our coordinates for all our vertices, what you want to do is slide the cutout triangle 4 units to the left and 3 units down as shown. So basically what we want to do is slide each vertex of our triangle 4 units to the left and 3 units down. So if I get my x vertex, 4 units to the left would be 1, 2, 3, 4, and 3 units down, 1, 2, 3. I'll end up with my x prime. Okay, so if I do the same thing for z, okay, 4 units to the left and 3 units down, so I'll get my z, 1, 2, 3, 4 units to the left, 1, 2, 3 units down. I go to my z prime, okay, and finally my y, 4 units to the left and 3 units down, okay, would be 1, 2, 3, 4, 1, 2, 3 would get me to my y prime. Okay, so after that we trace the triangle, we end up with our blue triangle, okay, and we label the vertices x prime, y prime, and z prime. So they correspond to the first triangle. Write the coordinates of the vertices of x prime, y prime, and z prime. So let's do that now. X prime is negative 1, 0. Let's do the black one. Z prime is, let's continue with the blue then. Blue, and we'll make it 10. Okay. So z prime is 1, 2, 3. That's 3, 0. And my y prime is 1, 2, 3, 4. 1, 2, 3. So the y prime is 4, 3. Okay. So we just moved our pink triangle 4 units to the left and 3 units down from the original coordinates to our new coordinates. So we're asking us, how are the coordinates triangle XYZ and triangle X prime, Y prime, and Z prime related? So let's find out. So remember when in our coordinate system, when we say 4 units to the left, like when we did our slope, okay, 4 units to the left means it's negative 4, or we moved it negative to the left 4 times. So negative 4 represents 4 units to the left. And since it's saying 3 units down, 3 units down represents also negative 3, because going up means positive, going down means negative. In the same way, going to the right means positive, going to the left means negative. So let's see what happens here in our coordinate x, which is 4, 3. When we moved it 4 units to the left, we subtracted 4. And when we moved it 1 unit to the right, okay, 1 2 3 4, 1 unit to the right, or sorry, 3 units down, we subtracted 3, okay, and this is actually, sorry, my x is 1 2 3, that's only 3 units, so that's my bad right there. Erase that, let me replace that with 3, okay, so this is actually, x is simply 3 3, 1 2 3 3 3, okay. So again, going back, our x coordinate is 3 3, so we'll change this to 3 3, okay, and when we moved it 4 units to the left, we subtracted 4, and we moved it 3 units down, we subtracted 3. So if you notice, 3 minus 4 is negative 1, 3 minus 3 will give you 0. So what do you notice? This is our x prime. So if you look at our point y, which is 8 and 6, let me double check that so we won't make a mistake again. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6. Okay, so y is good. Okay, and then we moved it 4 units to the left, 3 units down. So this becomes now 4 and 3. And that's what our y prime is. And finally, our point x, sorry, our point z, which is 7 3. We moved it 4 units to the left and 3 units down. We end up with 3 and 0. Very much the same as our z prime. Okay, so what we've done here is we've actually translated triangle xyz, 4 units to the left and 3 units down, and the result was triangle x prime, y prime, and z prime. So how are they related? Okay, triangle x prime, y prime, z prime is a translation of triangle x, y, and z. Okay, and this is our lesson for this particular uh, topic right here in transformations. And definition of a transformations, there are movements of geometric figures, and definition of a translation, which we just did in our activity, is a type of transformation. Okay, in a is a type of a translation, I'm sorry, is a type of transformation. So we've just translated our triangle xyz to triangle x prime, y prime, and z prime. So in a translation, we basically slide a figure horizontally, vertically, or both, as you did in the activity. So what we did here is we slid our figure, the pink figure, to the left and down. Okay, so sliding is a type of transformation called a translation. So let's look at another transformation. Okay, and this is now a rotation. Definition of rotation: you can turn the figure around on a point. Okay, computer drawing packages allow a user to create drawings. After the drawing is created, a command called rotate right can be used to rotate the figure as shown at the right. So when we're going to rotate the figure, okay, we need to find a rotation point, a center of rotation. And in this case, our center of rotation would be probably this point right here. Okay, so we basically put our finger on that point and we rotated the triangle clockwise to the right. Okay, so let's take a look at example of rotation right here. So not that one, that's it's another number. So let's open up my GeoGebra and let's see how a translation would look like. Let's do a new window. Okay, and let's minimize this. That will come in handy later. And let's do the grid. Okay, so in a rotation, you are going to rotate on a point. So let's say we have a triangle. Okay, and let's do a similar triangle that like the one in the book. So let's do this triangle right here. okay, and we want to rotate this triangle, okay, on this point right here. So what we want to do is we want to rotate that triangle around the point, okay. So let's say this is our triangle. We want to rotate that triangle around this point, okay, and let's say we want to rotate it by 90 degrees, okay, clockwise. So that means clockwise is going up there, and if you look at the result, that's how our triangle would look like. It was rotated 90 degrees clockwise. So basically, if that's your point, it made an arc 90 degrees going up. So if you want to do the same thing from the example, the center of rotation is actually down here. So if we repeat that, we want to rotate the same triangle, okay, and then our center of rotation would be here. Look what's going to happen. If I create my center of rotation to be here, okay, we need to make a point first. And let's make a point right here, right there, and let's rotate this again, get that triangle. No, it's not it. Okay, let's continue doing that. There you go. And we want to rotate it. Let's do this again. Let's see it. And let's choose this point right here. So I want to work that one. Okay, it works there. I just want to work here. There. Okay. Get that point of rotation right there. And we enter 90 degrees clockwise. There you go. Okay, so we moved it 90 degrees, and that's how you rotated that triangle. So our rotation is basically holding down a point of one vertex and moving the triangle over a center of rotation. Okay, so in this case, this triangle, the center of rotation was here, okay, center point, and in this triangle right here, the center of rotation was here. Okay, so that's a good example of rotation. We'll not go deeply into rotations because you're going to do that more when you get to high school. Okay, so another type of transformation is what we call a reflection. So when you flip a figure over a line, you can use a geomirror to draw a reflection. I think we'd used a geomirror last year for this one. But basically, each diagram below shows its figure and its reflection over a line. You're basically flipping the figure over a line. Place a geomirror on the dashed line in each figure and verify each reflection. So a geomirror is basically a type of mathematical device that when you put it over a line, you can see the reflection, you can actually trace it out. So when we talk about a reflection, let's make a new window here. And let's not save this. So when you want to find the reflection, let's go back to a triangle. Okay, and let's create this triangle right here. Let's make a funky little triangle. Let's rotate. Let's reflect this triangle. Let's say over this line. Okay. Oops. Okay. Not do that right. Okay. Let me redo that again. So you want your triangle. There you go. Okay, and you want to rotate it over a line. Let's say this is the line you want. Why is it still there? Okay, undo that thing again. There you go. Last time. I think I got this now. Okay, and you want to rotate it over a line. Reflect it, okay, over a line, and we create our line. let's say we want to reflect it over this line right here. Okay, remember in reflection we want to flip our triangle over that line. So just like a mirror image, you're flipping that image. So if I do that and I reflect it over that line, okay, so I simply get my triangle, choose the line of reflection, which is this one, and that is the mirror image of this particular triangle. Okay. Now, one good thing about reflection is that you can do this with any type of figure. Let's say I want to reflect uh, this happy-go-lucky dude, and we want to reflect it over a line as well. Okay, so we want to reflect that dude over a line, and let's say this is the line that we want. No, that's a point. That's not a line. Let's say this is the line that we want right there. So we want the mirror image of this stick figure dude over that line. So what we simply do is choose the dude right there, and that line, hold on, it's not being chosen. There you go, that dude and that line. Look what happens. Nothing happens. Let's do that again. Oh my goodness. Oh my goodness. Okay, let's do that again. There you go. There you go. Oh, finally. So he basically reflected that dude over that line. So our reflection is basically flipping the figure over a particular line. And that's the same way with our examples right here. This figure was flipped over that line of reflection. This blue figure was flipped over this line of reflection. And this figure was flipped over that line of reflection. Okay? So a reflection, a transformation that's a reflection, is basically flipping the figure over a particular line, and that's your line of reflection. Okay? And those are our three transformations. But before we move on to our examples, okay? Well, actually, we can move on to our examples. Okay, and this is 17. Okay. Before we move on to our examples, let's do number 17 and number 18 first. Okay. So if you look at number 17, it says graph point A, which is negative 1, 3, point B, 4, 4, and C, 2, 1 on a coordinate plane. Draw a triangle ABC and graph its reflection if the x-axis is the line of reflection. Okay, so I did this already, and this is number 17 right here. That is the triangle that was formed by the three vertices given. Okay, and these vertices were, let's put this down a little bit, negative 1, 3, okay, which is A. I'll put A here. Okay, this is point A, and you have 4, 4, negative 1, 3, this one, and you have 4 and 4, which is not that one. My goodness gracious. I think this is the one. Negative 1, 3, yeah, this is the one. So this is A. Okay. Okay. So this is point A, and you have, let me just minimize this, 4, 4, which is this one right here, and 2, 1, which is this one. So this is point B, and this is point C. It says there, draw triangle ABC, which we did, and graph its reflection over the x-axis. The x-axis is this line right here. So what we're going to do is we're going to reflect it over the x-axis, and let's maximize this first. Okay, and for you to be able to reflect this over the x-axis, there are a few ways to do this. Okay, it says reflect it over the x-axis, so all you need to do is get a mirror image of that triangle over the x-axis. So a good way to do this is find out the number of units C is away from the x-axis, which is 1 unit. So you basically draw a point right here, okay, right there. My goodness. There, okay. There you go. Cheese sticks. So this becomes our C prime. Okay. And we know that this is 1, 2, 3, 4, 5 units away from the x-axis. So we count 5 units. 1, 2, 3, 4, 5. So this should be our B prime. Make that point. Okay, let me erase that thing. This is our B prime. There you go. And let's put our A prime before this messes up again. So we have 1, 2, 3 units. A is point A is 3 units from our x-axis, so we count 3 units down. 1, 2, 3 units down. Okay, 1, 2, 3 units down. This becomes our A prime. So this is our A prime, and this becomes our B prime. And all we need to do is connect those points. Okay, that point connects to that point, connect to that point. We have reflected triangle ABC over the x-axis. Okay, and that's how you reflect, okay, a triangle over a particular line of reflection. In this case, our particular line of reflection is the x-axis. Okay, and let's do number 9 really quick. Hopefully this cooperates. Let's take that out. We're done with this one. Number 19 is point R is 3, -1, S is 6, 2, and T is 1, 4. In a coordinate plane, draw triangle RST and translate the triangle 5 units to the left and 4 units down. So this is our triangle. Not that one, of course. We're done with that one. Don't want to save it. This one is the one we're not done with. Okay, so we have, let's name our point, triangle RST, where R is 3, -1. And this is R. This is not A, this is R actually. So there you go, that's R. Okay, S is 6, 2, so this is S. And T is 1, 4, so this is 1, 4. Okay, so it's saying we want to translate it 5 units to the left and 4 units down. Okay, remember at the beginning of the lesson, okay, 5 units to the left. So when we say 5 units to the left, it means -5, 5 units to the left, and 4 units down means -4. So basically we subtract 5 from our x coordinate and we subtract 4 from our y coordinate. Or we can just do, okay, we can just basically do, make that again, okay, we can just move it -5 units to the left and 4 units down. Okay, so let's try that. 5 units to the left means 1, 2, 3, 4, 5. Oh, it's out of our screen. So we need to move everything right here. Okay. And let's bring this here. Nope, we don't want that. Sorry. Nope. I'm simply getting this. Okay. Okay, so you get the point. So this is 1, 4, and we want to move it 5 units to the left. So from that point, we do 1, 2, 3, 5 units to the left, and then 4 units down. 1, 2, 3, 4. So that's our new point right there. And then we move every single vertex 5 units to the left, 4 units down. So 1, 2, 3, 4, 5. 1, 2, 3, 4. And this one, 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, so this becomes our S prime. This becomes our R prime, and this becomes our S prime, and this becomes our T prime. Don't mind these, I don't know how to erase that for now. Okay, so what we need to do now is simply connect those points. Okay, connect those points. There we go. And that is the translation of our triangle RST. Okay, we moved it 5 units to the left and 4 units down. Okay, now if you want to find out how to do this without all that jumping around in the coordinate plane, all you need to do is get the coordinates. Okay, so in this case the coordinates are 3, -1. You have 3, -1 right here, and then 5 units to the left, 4 units down. So this becomes -2 and -5, and that is R, and this becomes R prime. And if you go back to our GeoGebra, that's what R prime is, -2 and -5. Okay, so if you do the same thing with S, which is 6 and 2, we subtract 5 and subtract 4, we now have 1 and -2, and this becomes our S prime. And if you go back to our GeoGebra, S prime is -1 and -1 and -2. So you can see you can do that with the same thing with T, which is 1 and 4, and you subtract 5 and you subtract 4, you end up with our T prime, which is -4 and 0. Okay, and that's how you translate triangle RST to triangle R prime, S prime, and T prime. Which brings us to example 1. Tell whether each transformation is a translation, rotation, or a reflection. Let's look at letter A. And if you look at letter A, okay, this pink figure was rotated over point A, so that it became that figure right there on the blue. So this is a rotated about point A. And letter B, if you look at this figure, the blue figure was flipped over the y-axis, which is our line of reflection. So that's a reflection right there. And figure C, we simply slid the blue figure to become the pink figure. So we slid it. By sliding, we know that it is a translation. So it was translated 2 units horizontally and 3 units vertically. Okay, so if you get the point, 2 units horizontally to the left and 3 units vertically down. Okay, so that's how we apply what we've learned. And there's another thing that we need to understand. When you draw a line and its reflection, you create a figure that is called a symmetric figure. The line where you place a geomirror, or the line of reflection, okay, is called actually the line of symmetry. So our line of reflection is also our line of symmetry. Some common items with a line of symmetry are shown below. So when you talk about lines of symmetry, okay, line of symmetry is that when you fold a particular figure, it folds exactly on top of the other figure and there are no overlaps. Okay? So when you talk about some items with the lines of symmetry, these are some items right here. And it's good to note, okay, that, okay, let's make this red. If you take this snowflake, for example, if I create my line of symmetry right here, this part will fold exactly on the other half. Okay, so if you also do that, okay, this half will fold on the other half. If I do this here, this half will fold on the other half. And these are all lines of symmetry of this snowflake, because when I fold it over that line, it will fall exactly on top of the other line without any overlap. This butterfly, for example, I can put a line of symmetry here, and those two will be exactly the same. Those two parts of the butterfly will be exactly the same. This kite, for example, put a line of symmetry. There it is. When I fold it over that line of symmetry, the two parts will fold on top of each other without any overlaps. Same thing with this star. Okay, these are all the possible lines of symmetry of this star. Okay, when I fold that over that line, okay, it will fall exactly on top of the other half without any overlaps. So if you notice, the snowflake has 1, 2, 3, 4, 5, 6 lines of symmetry. A butterfly has 1, kite has 1, star has 1, 2, 3, 4, 5 lines of symmetry, and the letter A will also have 1 line of symmetry right there. Okay? So let's talk about this. Think about it. How many lines of symmetry does a square have? How many lines of symmetry does a circle have? So if you notice, a circle, a perfect circle, and a square will have both. The circle, of course, will have an infinitely many lines of symmetry. A square will have 4, and we'll learn that in example 2. Okay? So if you look at this, all the lines of symmetry for the kite right here, the kite has only 1 line of symmetry, because that's the only place where you can fold the kite and the two parts will be exactly the same and there will be no overlaps. For this particular square, it would be the line of symmetry would be here. Oops, that's not that center. Make it center. So the line of symmetry would probably be here. There you go. That's one line of symmetry. And there's another line of symmetry. Okay, if this is a rectangle, there will only be 2 lines of symmetry. Okay, in the book, it is represented as a rectangle. So we name this a rectangle, 2 lines of symmetry. And a kite has 1 line of symmetry. But if this were a square, it would have 4 lines of symmetry, because let me draw you a square right here. If this were a square, and I'm going to draw lines of symmetry, this will be 1 line of symmetry. This will be another line of symmetry. Of course, I'm not drawing it to scale, and that will be another line, that will be another line. And that's the reason why there are 4 lines of symmetry in a square. And a triangle, okay, in an equilateral triangle, that is. So you have 1, 2, 3 lines of symmetry right there for an equilateral triangle. So an equilateral triangle has 3 lines of symmetry. Okay, secret word for this particular lesson would be beach. The secret word is beach. And the final example: artists have used symmetry to create beautiful designs for centuries. In 1895, excavators found Hopi poetry among the ruins of the pueblo known as Sikiataki. The pattern below was found on the exterior of Sikyatki football. Describe the transformations used to make the poetry design. So if you notice, you have this triangle and became that triangle. So this is basically a good example of Translation, because the original design is translated to the right and rotated 180 degrees or reflected over the horizontal axis, a horizontal line. Okay, so you have a good example of a transformation. Okay, because it is a translation. Okay, a rotation, and at the same time a reflection. Okay, and that's our lesson. Thanks for watching.